Hi everyone, welcome back to the channel. So today in this video lecture we'll be learning about trees. So you can say this is a tree series. Here we'll be learning about trees, its applications, its algorithms, and we'll be also solving problems related to trees. Problems from judges like lead code, CSCS, as well as competitive programming problems. So in this video, this is the introductory video where I'll be listing out the entire game plan, as well as I'll be teaching the basics of trees, why do we use them, and the basic terminologies related to trees. So what are trees? Trees are basically non-linear data structures. So non-linear data structures. So as we all know that we have linear data structures, which includes arrays, strings, linked lists, stacks, queues, and so on. These are non-linear data structures. Why they are called linear data structures? Because the data is stored in a linear fashion. While here in this case, the data is not stored in a linear fashion, rather it is stored in a hierarchical way. Fine. So let's understand it with an example. So take the example of a college system. So we know that in a college, at the topmost part, we have director. Okay, this is director, or rather say beloved director. Now, below this director, we have say deans or principals. And now below these principal or deans, we have HODs. So they are HODs. Okay, and then we have teachers below these HODs, and finally we have students, right? We are like finally the students are here. So this is a student. So there is a particular hierarchy for this organization which we must follow. A student can directly report to teacher, but not to the director. Okay, until unless he or she is a very good student. And there is a certain type of hierarchy we can see, right? These are levels of hierarchy. Topmost level, then we have lowest level. Okay, like this. So this is an example of a typical example of a tree. So if I give a definition, so by definition tree is basically a special graph, so which has n nodes, n minus 1 edges. That is a tree. This is the first point. Also, it's a special graph where for every pair of nodes, so take any two pair of nodes A and B, we have exactly one path. There is no more than one path. Like in graph, we have more than one path, but in a tree, we do not have more than one path. Like here in this example, we can see that if it is a tree, then take any two nodes. So take this node, let's say this one and this one. So between these, we have exactly one path, this one here, which goes through the root node. Okay, take these two nodes. We have one path, exactly one path. So that is the properties of a tree. Third property is the tree is basically connected. A tree is connected and it do not have any cycle. Do not have cycle. Fine. Let's discuss about some terminologies of a tree. So let's first draw a tree. Okay, so this is a tree, typical tree. This is root node. So the node at the top of the hierarchy is basically a root node. This is the leaf node. The node at the lowest level of hierarchy is the leaf node. It has one, it has degree as 1. Degree as 1. Degree is basically the number of edges which are either like the number of edges which are going out or in from a given node. Like here the degree is 1 because we have one edge from this node. For this node, which is node number 1, the degree is 3. We have 3 edges. We have 3 subtrees connected to this node. Okay, so let's talk about the next thing, which is parent. What is a parent? Like here we can see that a parent is basically like, for this node, what will be the parent? For the path from this node, let's number the nodes: 2, 3, 4, 5, 6. So from this node 6, take the path to the root node, which will be this. We know that there is exactly one path from this node 6 to node 1 to the root node. The very first node in this path is basically the parent. So from 6 to 2, then to 1, what is the first node along this path? It is 2. And this is the parent for 6. So that's the definition. The definition for a parent of a node is the first node along the path which goes all the way up to the root node. Like from this node number 6, the path goes like this: from 6 to 2, then from 2 to 1. The first node along this path is this node number 2, and that is the parent for node number 6. While node number 6 is a child node for node number 2. Okay, so for node number 1, what are the child nodes? 2, 3, and 4. It has 3 child nodes. And these 2, 3, 4 are siblings of each other. They are called siblings. So we know that what is a parent, what is a sibling, what is a child. Let's talk about the next term, which is ancestor. What is an ancestor or ancestors? Now for node number 6, all of the nodes which come along the way to the root node are ancestors of that node. Like here for node number 6, the path contains node number 2, 1, and 6 as well. So all of these nodes are ancestors for node number 6. Node number 6 itself is node number 6 is also an ancestor of node number 6, as well as node number 2 and node number 1. Okay, so the definition is simple. All of the nodes which are present along the path from a node all the way top to the root represent the ancestors of that node. Okay, now let's talk about the depth and level, the next concept. What is a depth and level? So the depth is nothing but the distance from the root node. So this is the root node. What is the depth for node number 5? It is simply the distance from the root node. So the distance is taken to be 0. This from the root node. We start from here. Now we count the distance. We move to node number 2. The distance for root number 2 will be 1. Then we move to node number 5. The distance will be 1 plus 1, that is 2. So the level or depth for node number 5 is 2. That represents the depth of a node. Fine, so let's discuss about a subtree. What is a subtree? So we want to learn about now this is the root node. What is the subtree for this node? Now all of the nodes which are the descendants of that node are present in the subtree of that node. Like here for node number 1, this set of nodes containing 2, 5, and 6 is a subtree. For node number 1, this set of nodes containing only one node, that is node number 3, is another subtree for node number 1. This set of nodes which contains only node number 4 is a subtree for node number 1. Okay, so that is the definition of, like, in other words, we can say by definition we can say like all of the nodes, let's write it, all nodes having 1 as an ancestor are or are present in the subtree of node 1. So this is a definition for this subtree. Okay, we can see that what are the nodes which have 1 as their ancestor. All of the nodes except 1, 2, 3, 4, 5, 6, all of them, they all have 1 as their ancestor. What are the set of nodes which has 2 as their ancestor? Node number 5 and node number 6. They constitute the subtree of the node number 2. Okay, so that's all. That's the definition for a subtree. In this video lecture, we learned about tree data structure. We learned about its basic terminology, basic terms, and in the very next video, we'll be starting with the tree algorithms, how to traverse a tree, how to basically implement a tree data structure, what are the major algorithms using which we can traverse a tree, and then we'll solve a lot of problems related to trees. So I plan to solve these problems of tree algorithms from this CSCS section. And apart from it, I'll also solve problems from Code Forces and Code Chef as well as from Lead Code. Some selected problems of interviews as well as OS. That's all for this video. If you like the video, then hit the like button